Welcome. Welcome to our office, and thank you all for coming out here tonight.
Yeah, quick intro. Jason from Arize. We're one of the leaders in kind of LLM, ML observability and evaluations. So excited to kind of talk with Robert here about the state of the industry. It feels like every week something crazy new happens. I guess Mistral dropped this week in a big way. So we'll be fun having a conversation here.
Yeah, and just to introduce myself, and we've known each other for a while. We got our start with Anyscale building Ray, an open source project for scaling AI workloads. And we have deep open source roots here, so very excited about the trend toward open source models and open source infrastructure and all of those components.
Yeah, I mean, I guess maybe on that one, start on the Mistral one. Does Anyscale support Mistral? Did that, like any thoughts on why it's caught everyone's attention? What's different about the model? Love to hear what you think.
Yeah, so we just launched support for Mixtral, the mixture of expert, the larger mixture of experts model this morning, and are already seeing a bunch of interest in that. I think people are excited about this model because of Mistral's track record with the previous model. The previous model, is doing quite well when we launched. When we launched Anyscale endpoints. So maybe I'm jumping ahead, but we launched one of the things we do here at Anyscale is we have an LLM API. It's an inference API. It's a fine-tuning API. It's an embedding API. So similar to the OpenAI API, but for open models. And when we launched it initially, it was primarily Llama models. So Llama 2, the 7 billion parameter, 70 billion parameter, 13 billion, Code Llama, these types of models. But when we launched the Mistral model, 7 billion parameters, what we saw is that a lot of people switched over. A lot of our Llama 2 7 billion parameter model users immediately switched over to the Mistral model, and it's been doing quite well. And a lot of our evaluations, it's done extremely well. And so they've had that track record, and I think that's why people are excited about the new Mistral model.
And have you any thoughts on like the performance differences or architecture? Mixture of experts. I think all of us were surprised. I mean, to be honest, I was a little surprised when I heard GPT-4 was likely a mixture of experts. Any thoughts on like how it's different? What that means to people? Any notes or ideas?
Yeah, it's a different point in the design space, right? And I think Jeffrey Hinton did some of the original work here, and Ilya Sutskever and other people did a lot of the. I'm forgetting a bunch of people. A lot of people did a lot of the original work here, and it's certainly got advantages. Inference speeds can be faster, right? So because you're not touching all the parameters, as frequently when you're doing inference. I think the training side can be more compute efficient, right? So you can potentially train larger models, but training stability can be more of a challenge. Mm-hmm. And you can have, there are all sorts of subtleties. For example, you have a bunch of different experts, and as you feed a batch of data in, your batch sizes might be very different for each of the experts, which can cause efficiency challenges. So there's all sorts of new challenges that it introduces, but it also has a lot of benefits. And it seems like an interesting enough point in the design space, given the inference time efficiency and also the training time efficiencies.
And in these cases, do you host the models for the Anyscale endpoints?
Yeah. So we do both. Well, we host the models. We let people query them through our API. Yep. And for people who just want to, write some JavaScript code or write some Python code to hit an API, we also let people deploy them themselves.
Got it. So kind of all three options. And then, do you fine tune the ones you host, or is it typically someone would fine tune something and then host it with you in some way?
Well, so through our and we have different users with who prefer different models, or when I say different deployment models. Yeah. Through our API, we provide a fine-tuning API. Okay. Right? And it's very simple. It's similar. It's the same as the OpenAI fine-tuning API. Yep. So you essentially upload your data, and you get sent to our fine-tuning API, and what you get back is the name of a fine-tuned model. So you get the name of a fine-tuned model, and then you can query that through our inference API.
Got it. And are you fine-tuning the mixture of experts models? Are you dealing with any
We
of those
didn't
challenges?
launch fine-tuning yet for the Mixtral model.
Okay.
Yeah.
So you'll be dealing with some of those challenges too. Any thoughts on
But just so I can say that this is what I just described was through our API,
Yeah.
but through our platform, which is much more expansive.
Yeah.
You can kind of do anything. You can use, we offer a fixed set of models through our API. Of course, you can request more, but through our platform, you can deploy any model. You can fine tune any model. You can do pre-training. You can do stuff offline. You could do, large scale embedding computations, whatever you want to do.
In terms of, I think on the current set of models, evaluations are probably the thing we're thinking about the most, and our customers are thinking about the most, and also like as you launch these new models, any thoughts on like evaluations, how you see them, how your customers are using them, how you're judging this model is better than another one right now?
So yes, I know you guys think a lot about this, and we also think a lot about this. It's hard to overinvest in the evaluation side of things because similar how it's hard to overinvest in developer productivity or testing or things like that for regular software development. This is what enables you to move quickly further down the road, right? So if you don't invest in good evaluations and you build your application and you deploy some model, you build your application with Llama or GPT-4 or whatever, and then a new model comes out. Some new, GPT-5 comes out, Llama 3 comes out, and you deploy that. Is it better? You have to answer that question. Or you fine-tune a model and you deployed the fine-tuned model. Did it help? Right? And sometimes you have objective metrics you can look at, like something around user engagement, right? Or some kind of user feedback. Other times, you don't have that feedback, and you're left in the dark unless you've spent time upfront investing in evaluation. And so when we work with customers who are early on in their journey of building RAG applications, building LLM applications, we generally encourage them to spend some time upfront, label some data points by hand, rank the quality of some things by hand, and as you go through the process of doing the evaluation by hand, then figure out how to automate that. Figure out if you can get GPT-4 to do evaluations in a way that matches your evaluations, things like that.
And I would say that we see both. So we see like human labelers. You got to label your data, but it's maybe some small amount. LLM assisted evals, which is something he's talking about here, which is we've been seeing more and more. And we also subtly look at LLM assisted evals as slightly different than I would say model evals, which is what drives the Hugging Face leaderboards. And I guess first off, did you all know like the Hugging Face leaderboards? I'm sure most of you do. How many of you trust those evals? Yeah, I don't trust them. The answer is no.
What evals do you trust?
I trust ones I hand create. So if I'm honest with you, it's the most trustworthy are off of your private data. So something you're trying to get something working internally. You have some great data points from production. The golden data set you've created. Those are going to be the best when you're trying to test something. I think there's definitely leakage problems. I mean, we were talking about this earlier of I'm sure all the training sets are running on the model evals of the leaderboard sets.
And it's very hard to avoid that.
Yeah,
it's very hard to detect it or it can be hard to detect in complex cases. Maybe you imagine you're evaluating your model on some math problems or some riddles, and you can search your data set for the text of those riddles or those math problems, but what if they were translated into another language? Or there's all sorts of ways things can leak in.
Yeah, and I think, and especially if it's driving a leaderboard, being at the top of the leaderboard means funding. There's a huge disincentive, huge incentive to get the test right, but maybe not the best general model.
Certainly, there's a lot of people publish papers in machine learning, right? And before starting this company, we were in grad school and doing a PhD at Berkeley. And people would sometimes joke that you could go to different machine learning conferences. And there were a lot of amazing research that people did, a lot of amazing papers people published. But without even looking at the experiment section of a lot of these papers, sometimes you kind of knew what they were going to say, right? They're going to say that their method is better than all the other methods. So there are some incentives in that direction.
It happens all the time. I mean, the one note is on the eval side that I feel like our bit of a breakthrough in the last month or two has been, we have a Phoenix, which we'll show later, with an eval library on it, but we added a flag for explanations. So if you're running evals and you're trying to debug your stuff or trying to understand why it made the decision it did, asking for an explanation, powerful. If there's one thing to take away, if you're building systems, that's my one advice and takeaway: try explanations on evals if you're ever trying them. It's been a sea change in at least the customers I've used it on the last month. And then I do think that evaluation, the idea of evaluation, is now everywhere. There's like, someone was telling me like 10 companies a week on evaluations, and it's almost an overused word. It means a lot of things to a lot of people. So I also think there's a whole education phase that's going to have to go on here. And what do you mean by it when you say it? And yeah.
By the way, there's also a difference between, explanations are extremely important because oftentimes the insights are what matter.
Yeah.
Now, a lot of people think that the LLMs are going to get better and better at generating explanations that sound correct,
Yeah.
right? Which is not the exact same thing as being correct.
Yeah.
Right? And it's possible that these models will be very good at just convincing you of things, better than they are at actually being correct.
And I can give you a concrete example of like we're evaluating a CodeGen customer. Customers integrated CodeGen into, it's a Fortune 100 company integrating CodeGen into the product. And the evaluation was saying like, okay, they want to know if it's functionally correct from a CodeGen perspective or not. But you add the explanation in, and it would literally tell you, okay, these APIs don't exist, or you can't add a vector this way. So you went from like percentage of code correct or not to actually, okay, well maybe in the context window we should add the API calls so it knows about these in more general detail. So you actually got how to fix the problem that the evaluation was detecting. So big, if you're doing anything, that would be my one note.
Certainly with reasoning tasks, we've seen that LLMs will, hallucinate and or make incorrect statements.
Yeah.
But in some fraction of those cases, they can tell you that they've made an incorrect statement, right? The same model can identify that mistake.
Very much so.
And so, as people build applications with LLMs all over the place, you have LLMs doing generation, but also like fact checking after the fact.
Absolutely. Don't be scared of LLM evaluation. I mean, the reason it works is it's just a much less complex problem. You're having it say yes or no versus like the original generation problem is pretty complex. Having it evaluate what it did is a much simpler problem than the original one, which is, it does work quite well quite often. So at least with GPT-4, the biggest models. But in terms of, in terms of kind of, switching tracks to like some of the other stuff you're seeing out there, like the functions and the latest function releases with Anyscale. What are your thoughts on the use of those and what you've done recently?
Yeah. Well, this is something I'm super excited about. Just a couple days ago, we launched function calls in JSON mode for open models. So many of you are probably, how many of you are familiar with OpenAI's function calling API? Okay, cool. So the point here is that you can query an LLM like GPT-4 and ask it a question, and you normally get a text response. You get a string of text. But a lot of the uses of LLMs, and especially where we see things headed, are that the outputs of LLMs are going to be consumed by downstream programs and not just read by a human, right? So as that happens more and more, it can be valuable. It can simplify your life to have structured outputs from these LLMs. And that could mean some kind of JSON object. It could mean, here's the name of a function, and here are the arguments you should pass into that function to call it. And OpenAI has this feature, but it was a big gap in the open source ecosystem. And so we launched that just 2 days ago. And you can now, on Anyscale endpoints, use the Mistral model to do function calling and output JSON objects. And we actually benchmarked function calling, our implementation, on a variety of open models, so the Llama models and so on. And one of the surprising things, or one of the surprising things, was that the Mistral model, the 7 billion parameter Mistral model, the small one, actually matched GPT 3.5's performance at function calling, which was not necessarily what you would have predicted ahead of time. And I think that also contributes to our excitement for the new Mistral model because of that potential. But this is, once we launched this, everyone was like, "Oh, this is amazing! This is such a huge gap. This is like why we weren't able to use open models in the past." And I think it's just a big deal for developers to be able to build applications.
Yeah, and I think there's something to be said too. I mean, it's really interesting. We're almost getting this like common layer on top of different models. Like functions that exist on OpenAI but didn't exist in. Maybe it's OpenAI kind of driving it, but you are getting this like common interface layer that now you're kind of making similar across different independent of the model type.
And also, of course, there are a lot of different API choices you can make here. We've made the choice to make our APIs as compatible with OpenAI's APIs as possible. So if you've already built an application with OpenAI using GPT 3.5 or 4 or whatever, then you can just, it's like a one line of code change. You can point it at Anyscale endpoints instead of OpenAI and compare the Llama models or other models side by side. So, and see how that stacks up.
Yeah, that's awesome. And so going more into the hype cycle, do you think the funding that was just announced from Mistral, do you think they're fairly valued? Like where do you think that's going? Like what? It's a big. Did everyone hear about the funding round?
Yeah, so Mistral just raised a bunch of money.
Yeah.
I mean, I don't really know what a fair valuation is, so I probably not the best person to answer that. But I do think they're doing awesome work.
Yeah.
I do think that they've made major contributions to the open source ecosystem.
Yeah.
And if you look at the dimensions of like talent, having good people, the technology, I think they're a lot of with startup, a lot of what matters is betting on the right trend. Like, are you just even working on the right thing at the right time?
Yeah.
And in their case, I think betting on open source and open models is a fantastic bet.
It almost feels like people are trying to figure out who's the open source version of OpenAI a little bit, like if they can grab that train. But it's an awesome team and awesome.
And by the way, with the open source side of things, there are different layers of the tech stack. There are the models themselves, right?
Yeah.
And Mistral is contributing to this.
Yep.
The Llama models are very important. And of course, there are tons of models on Hugging Face.
Yeah.
And where we fit into the stack is, beyond the models, you need the infrastructure to run the models.
Yep.
This could be for training, for fine tuning, for inference, for running embedding computations. And you really need these two pieces to work well together in order to do AI.
Yep.
And where we sit is really trying to build that open source infrastructure for running the models.
And so in terms of I don't know if did anyone see the two graphs? I think Jan can put it out, but it was like, is open source going to overtake the closed source? Did anyone see those two graphs put out now?
I saw a graph.
What do you think?
What's
your bet?
There were two lines that they were converging, right?
Yeah, exactly. What's your bet on, at least on the LLM side?
Yeah. So I have a lot of opinions about this. I think open models are going to be dominant for a huge range of use cases. Okay, and this is not to say providers like OpenAI and Anthropic won't be the best in certain domains, right? They're, they've done a fantastic job, and I think they're going to continue to output high quality models. But I think for quality, and right now quality is probably the main thing people care about when building applications, right? Because LLMs are, this whole thing is fairly new, right? LangChain is like, how old is LangChain? I don't know,
It's
1
maybe a
year?
year. Yeah.
Okay. And so the technology just became good enough, recently became capable enough for people to start building the kinds of applications that they're building. And a lot of technologies like, fine tuning and these other things are also, I mean, people have been fine tuning models for a long time, but fine tuning as a really big part of application development is relatively new as well. So because this technology is fairly nascent, we're still working on making it good enough to build your application. And so quality is the top priority thing. But we see companies go through this, different phases of adopting generative AI where they're prototyping, they're experimenting, they're starting with a general purpose model that's good at everything because it's just easier. And at some point, they validate the application they're trying to build. They get it working, they're happy with it, and their users love it. And it's really about making it real, right? Really about thinking about, okay, how do I reduce the latency? How do I reduce the cost if I roll it out to all of my users? Right? How do I scale it? How do I make it reliable? Yep. And at this point, a lot of businesses reach the conclusion that what they need is not a general purpose model that's good at everything, right? They need a specialized model or a number of specialized models that are very good at specific things and are a lot faster and a lot cheaper, especially if you think about organizations that have, especially if you think about applications that are, not just going to have a single LLM call that you call and then you get the response and you read it, but if you have applications that have 5 or 10 or 100 model calls powering, the product, and these things are all composed together, there's going to be a huge premium on latency and cost and things like that. And so I think as model quality improves across the board, like GPT-5 is going to be better, Llama 3 is going to be better. These things are all going to be way better. You'll reach a point where all of these models are actually good enough for a large range of applications. And at that point, the dimension that people, the criteria that people use to choose these models can change rapidly from focusing just on quality to being about latency or cost or customizability or other factors. And so I think this will, you'll see shifts here over the coming year.
Yeah, so big bet on open source. I would bet there too. I feel like even more, like you would have caught me in the beginning of the year, I probably would have leaned more like closes as a, open's bridging the gap. So I'm now squarely in saying I'm agnostic and not
also
making bets.
Yeah, I'll just add to that. Everyone's going to be using model routing. Like people are going to be, there are going to be a ton of applications or companies that just help you send the query to the right model at the right time. And, I think there's a good chance that by doing this, you'll be able to get the quality of the highest model across the board, but at the cost or the, of the cheaper models.
Yep, agree.
Assuming you have some spread in like the nature of your queries.
I don't know if there's other subjects you wanted to talk about or go through, but it's kind of the big ones I had. I did want to know, how many of you saw the needle in the haystack kind of needle retrieval stuff going around about a week or two ago? Any
I might have missed this one. Which
hands of anyone see that? Okay, so there's a couple of hands. So it's kind of like an Anthropic versus GPT-4 testing retrieval, and basically was running a needle through the context window, looking at like how well, and by needle it's just like a little fact embedded in the context window can it return that fact, and so you move the fact around and you see how well it can return that fact, and it's just it's one example in my mind of like. Why evals are important. And the reason that those tests were important is because retrieval, connecting your model to private data is really important. So retrieval is important. And Anthropic's, the visual with Anthropic, it was all over the place. Like it was quite poor to retrieval, which is what frankly I've been seeing in practice, but those results tended to show it. So my note to all of you is like, like evaluations, my last plug is like I do think evaluations are going to mature in a lot of different ways. You're going to see evaluations for a lot of different things, and we'll learn the limits and strengths of the models that we have. There'll be certain models that are good at certain things, and exactly what the routing comment is. But on that needle and haystack retrieval stuff, we'll have some. We've been working with Greg on some research that will roll out this week with the similar stuff. So we've got a more rigorous approach on more models. But again, watch the eval space. I think the eval will help drive you what model is good enough for your task, and make those decisions.
Yeah, that sounds like a really good evaluation. And I mean, just the fact that you can stick in 100,000 tokens doesn't, mean it's going to significantly improve the quality. It's actually going to, be able to answer questions based on all that information.
Yeah, I mean, the quick takeaway was the ones with the biggest context windows actually were the ones that worst at actually using it. Mm-hmm. I think that's by far what we're seeing in some cases. So,
yeah. I mean, one of the there are all sorts of limitations across the board, including especially if you think about things like RAG, where we've sort of determined that one of the best ways to, there are only a couple ways to get your data into these models, right? One is by putting the knowledge into the weights through, say, training or fine-tuning, and the other way is by putting it into the context.
Yep.
And so RAG is an awesome technique for anchoring your generation to specific data that you have and information that you have. But there are a lot of questions you may want to ask, which are just the answer is not contained in any one fragment, any one chunk, or any two chunks. And if you just think about something as simple as, what was chapter 9 of this book about? I have, which involves reading chapter 9 and figuring it out. It can be quite challenging to handle simple things like that with RAG.
Yeah, I agree. I mean, my take is that you kind of have we've been talking internally about like level 1, like using what's in the context window, but then there's this whole steps of like how to manage what information is in the context window. There's planning, which is like how to fit that in, and part of one of the things we've been debating is, do we think the market's going to go more co-pilot, which is simple planning, I guess, versus like agent, which is like fairly complex planning. And I just don't know if GPT-4 is up for complex planning right now.
Yeah. For evals, I'm curious, how do you think about, when you think about evals, do you think about evaluating LLMs, or do you think about evaluating just overall systems, or,
Yeah, I mean, so we break it into, we actually don't care about model evals, and we call them model evals, like the leaderboards, the stuff that drives the leaderboards, means I actually think it's very, very useless to us and our customers. Most of what our teams our IC teams doing are what we call like task-based evals, which is a model and a template together, using those two on a task. So an example of that was like the code gen one I gave you, which is, is the evaluation is the code functionally correct? That's the task you're after. And it's not just a model, but it's a model and a template that says, is this code functionally correct? Describe if it's, what the problems might be. Describe if it's the wrong API. You've given it a task, and then you're running that over data. So it's like, you're running over the eval. In that case, it was an LLM generation task, but you might have question and answer where you're doing it at the highest level. I have examples with people doing human versus AI, so ground truth versus the AI answer. Is that correct? I'm looking at this paragraph and this paragraph. I've seen examples of link citation correctness. So is the text on the citation answering the question? That's a task. So task-based evals, I see used a lot. Not like the model ones, the sort of model on a leaderboard are not very useful. Yeah.
And of course, as as you get more and more agents that are more and more capable, I think that'll open up the door to having really meaningful evals. In fact, that, for example, if you have an agent that can make decisions to buy and sell stocks and can, there's a very real eval there, which is very meaningful, which is like, how much money are you making on this on the stock market?
Yeah, I mean, definitely the ground truth matters a lot there, I guess. But
You
whether
can't
it's
game that
working,
one as
yeah,
much with like.
yeah, you can't fake. Well, you can't fake that. Um, but yeah, and so though I see like little relevancy values, which are very tiny spot in the system to like whole system. Like, is the answer correct? And both are useful.
Yeah.
Cool. Any questions or any people have?
Talking about evaluations, out there that are I think you always talk about LLM check it.
Mm-hmm.
How effective those are.
Yep. Yeah, so we actually recommend, so if you're creating a model to evaluate another model, which is happening a lot, surprisingly. I mean, we're a year in, and people are doing it in I would say, what was not happening is now happening a lot. Most of those times you create a test set. So like maybe traditional data science wise, you've got a set of answers are correct, and then you're grading the performance of the LM first before you like really let it go. So you're kind of gut checking, does this make sense? You've got some performance metrics on it. And then once you feel good about that, you kind of, it gives you, and what's amazing, I had kind of Lou from Bizarre Voice, one of their kind of head DS guys was talking about evaluations publicly with us in a session. He was saying what's awesome about it is I can hand label like 100 examples. I don't need that many to like make sure this thing is kind of running correctly. So you get a lot of scale. Like you label 100 things, and then you now have this evaluation LLM that kind of labels the rest of your data for you. So he was saying that he used to pay people, pay a lot of money to get a set of labels on his data. Now you can do it really quick. But yeah, LLMs on evaluating LLMs, it's happening in a lot of places.
Yeah, definitely rather have 100 high quality labels or samples or something like that than, if the quality is low, then going from 100 to 100,000 is not going to help you too much.
Yeah, and I think like normally when we're training in the old world when we would train like image models, you couldn't do it on 100 labels. It's just, but in this case, you're just trying to get a gut check on the model's performance, the eval's performance.
What are some good use cases?
Yeah, good use cases of fine tuning and
Yeah.
anti-patterns. So I think of fine tuning as a way to reduce cost and reduce latency in a lot of cases by allowing you to achieve the same quality with the smaller model. Okay. Now that's not the only way to use fine tuning, right? You can also use it to take the same model and improve quality, but that's one of the most common ways I see it being used. Now, this is something where examples of tasks we've seen fine tuning working really well are things, first of all, things that are stylistic, things that involve generating output in a certain format. SQL query generation is a good example. Areas where we've seen fine tuning struggle are problems that are kind of require the development of better reasoning capabilities. So, for example, solving math problems. If the model is not doesn't know how to solve math problems out of the box, from the base model, then fine tuning it on 100 or 1,000 math problems is probably not going to teach it enough. So this is an area where, unless you fine tune it on so much data that it really looks more like pre-training. So those are the areas we've seen that it hasn't worked as well.
Yeah, and I probably would add to that the anti-pattern as like putting your own private data in. I feel like a lot of people jump to fine tune when like context window and RAG is the right solution there. So like feeding your own private data in. Maybe it's good for the stylistic thing, and maybe I wanted to answer always about my product, but it's really not the core thing you should be thinking about. Retrieval, private data and retrieval should go hand in hand.
And by the way, for something like an end-to-end RAG application,
Yeah.
of course, you can always fine tune the model that's doing generation, but it's a whole pipeline, right? And there are different, you have to ask yourself, where is the room for the most improvement? Is there more room for improvement in retrieving better stuff, or is there more room for improvement in generating better stuff given what I retrieved? And
Good point.
yeah, and this is why you have to look at stuff, what's being retrieved, and look at stuff by hand. But you can also fine tune embedding models for trying to improve the retrieval side of things, right? And of course, the techniques people employ go beyond just fine tuning. Fine tuning is important, but you can also add in, additional retrieval through like keyword search and stuff like that. And you can also use models if you retrieve extra stuff, you can use models to kind of do a second pass and rank the stuff you retrieve to decide what to feed in. So there are many knobs you have here at different stages in the pipeline, which could be the bottleneck.
I think that's a good point, that the fine tune, the retriever embedding portion, good case for that in a number of cases. So again, it depends on how good your retrieval is doing, and but yeah, good point.
Go ahead. Yeah. Yeah. So if you have an end-to-end system, how do you think about testing it? Right. Do you want to take that one?
Yeah. So what we've been doing is kind of breaking things apart. And most people, I'll take what the most common case is trying to troubleshoot retrieval, or RAG systems, and it could be Q&A on your docs or whatever. So what we're typically doing right now is building evals for maybe for the retrieval portion. So maybe you're looking at chunks and seeing if the chunks were correct and evaluating your retrieval portion of the system. We typically will have evals that look at correctness or overall performance. The human versus AI has been actually really good to also look at the retriever side. So it's a set of evals that look at like either components or overall, and then combining those to debug. An example that wasn't obvious is, I'll just give you one example that we're working through the other week with a client. It was in a docs. It was an answer to a question by AI, and it had a couple different answers, but it didn't list all of them. It was like a feature set, right? And it had 3 of the 5. And when the human labeled it, they said, okay, this looks correct. But the human versus AI, the human answer had all 5. The AI only had 3. And so the AI caught it and explained it. So the explanation was pretty helpful. It said, okay, you're missing 2. So then the question is like, why? Well, you got to go down to the chunks and look at, well, were those answers even then chunks returned in the retrieval? So it's like using the evaluations to guide you where the problems are, but then you're still having to troubleshoot and debug, and then have the tools in place to do that like you do in the other system. So some of these things, in that case, the chunk wasn't in the chunks returned. So the question's then, well, why isn't it returned there? That case, it was actually a table that wasn't extracted correctly, and so the chunking and extraction was the problem in the system. So it's kind of like we're in another level of debugging, but evaluations and explanations, I would say, are big to it.
Yeah. I'll just add, I do think you need to test the individual components.
Yeah.
So similar to regular software development, why is it important to test the individual components? It's not just to help you get the thing working, but it's also so you have the confidence to go and change different pieces later on, because new models are going to come out, new embedding models, new foundation models, all sorts of things, and you're going to your software is going to evolve. Just as an example, we work with a lot of companies who do large scale embedding computations, right? You're throwing, you want to build your RAG application, you're throwing your text at your documents, your images, all sorts of different types of data, and computing a bunch of embeddings. Well, the first thing you want to check right after that is just, are your embeddings any good? Yep. And the answer is not necessarily yes. So you have to, but if you don't do that, and then you want to swap in a new embedding model later on, or try out something else, and something goes wrong, it's just essential for tracking it down.
Got to RAG LLMs, obviously. Now, curious, use one
Yeah.
we did a sense, where do you see LLMs actually making a difference in all this?
God, that's a good question.
So where do we see RAG, like LLMs, making a difference? What kind of use cases is it going to be most useful for?
Yeah.
Well, I think it's going to be used all over the place. I think most applications will, like fundamentally, most applications will rely on, data being fed into the LLM, and I think feeding it into the context is one of the, most important ways to get it in, or one of the few options you have for getting data in. And I think where this will head is you'll have, right now we have these fixed context windows of 32K or 100K, but you're going to need to get to the point where these models can effectively operate with infinite context. You'll have chatbots that are these perpetual chatbots that remember everything you've ever said to them, or that can answer questions based on all the information out in the internet. And so I think you'll get to the point where you have the appearance of infinite context.
I would say like a really good RAG app, I would say, is Perplexity. I don't know if you've heard Arvind, but he's like, we're just a big RAG app. And so if you want to see how well it could be done, that like look at that product. I don't think anyone's doing it well. Like they're doing it really well. I'm watching a lot of people do retrieval, and very few. It's easy to get the Twitter demo up. It's hard to just make it really good. And so I think we're just in an early stage of being able to like improve and tweak. And again, like I think it's evaluating your search and retrieval, just making sure the retrieval is really good, using metrics and tools. But I think I'm seeing enough people do it, and enough quality, really high quality engineers leaning in. Like you're gonna get amazing tools to make this stuff good. And I think when it really works, you get the Perplexity feeling like the stuff really works. The response is better even than like you have Google level performance on beating Google in a lot of things, and even beating OpenAI in certain subjects. So and that's using OpenAI as a base. That's my take. Retrieval is really important. Getting it right's hard. Getting it beyond the simple poor demo where you're stuffing in chunks and not debugging those is where most people need to get to. Cool.
Yeah, go for it.
Can you talk about like hosting Mixtral, like how that is? So typically when you guys host like a 7B, 13B, 34, all those sizes. So with Mixture of Experts, you're not really sending queries through all the weights. So like, what is it like on your end, hosting it, deploying it, serving it? How would you kind of stack it up in terms of like other model sizes, just for you guys?
Yeah, that's a great question. So first of all, we just started hosting it this morning. So there's a lot more to, to learn there. But one of the key differences is that it's more compute efficient at inference time. So that can translate into higher throughput or other kinds of factors. And a lot of the optimizations we do, there's a very deep tech stack around inference optimizations, right? At the GPU level, at the model level, the CUDA kernels you're writing, techniques like speculative decoding. There's a lot going on there. And I think it's an incredibly promising direction to be just because of that inference runtime efficiency.
How does it like stack up compared to other model?
Quality-wise, or how does it?
Hosting and like deploying, like other model parameter sizes, like is it similar to like serving a 13B? Or?
Yeah, it's more similar to serving a 13 billion parameter model than than a 56 billion parameter model or whatever, or 47 billion parameter, whatever it ends up being. Yeah, it's a great question.
Two more questions.
Okay, go for it.
Presume, I know you're not offering it as part of your product yet, but I presume you're playing around with fine-tuning Mixtral internally. You speak to how that's going. Is there something that model architecture makes specifically more difficult?
So I can't share anything yet about how it's going, but generally I can say that fine-tuning and training broadly for mixture of expert models does introduce new challenges, both around the overall training stability as well as around efficiency. It has benefits in terms of efficiency because it can be more compute efficient, but it also has there are challenges, can be challenges with maximizing, because you can think about a load balancing problem across the experts, and so a lot of the tricks that people try to do are aimed at essentially doing good load balancing across the experts to increase training efficiency. Yeah. And maybe one more in the back. The question is, so why not, are you saying, yeah, why not use all the cloud providers and compute resources and train like a mixture of not just 8 experts, but of like 1,000? That's a fantastic idea. We should definitely do that. Yeah. Yeah. I don't have a good reason for not doing that. Yeah. But thanks for the suggestion. Cool.
Awesome.
Thank you all so much.
Thank you.
Want to use this?
No, I'll use the.
But you want to share your computer?
Move these chairs.
Stop sharing.
No, you keep sharing.
Oh, keep sharing? Oh, God.
Danielle, I'm just going to put this mic here.
Awesome. So now we have Akshay, and he is Anyscale. He's going to walk through our portion of the tech talk, and then we'll hand it off over to Frisco from Arize. So go for it, Akshay.
Cool. Can you all hear me? Okay, good. So I'm going to talk a little bit about fine-tuning with Anyscale endpoints that Robert showed earlier, that talked about earlier. And then Kiko is going to talk more about the evaluation tools that Arize is building that Jason touched on. There we go. So Anyscale endpoints, Robert touched on this earlier, but it's our API-based tool to serve and tune these large language models. So we have some of the most latest and greatest open source models out on the platform for you to use behind an API. So at the core of Anyscale endpoints is really the cost, efficiency, and performance. And this is built up it's kind of a full stack optimization. We are using Reserve under the hood, which is our open source model serving framework, which comes with built-in auto-scaling, advanced capabilities like model multiplexing, multi-GPU modeling. And then we have Anyscale services, which is our hosted platform on top. And Anyscale, the platform, allows us to do things like go multi-region, go multi-cloud, look at places where the GPUs are cheapest without sacrificing on performance. And on top of that, we've made a lot of efficiencies at the single model GPU layer. So we've optimized the kernels, we've implemented techniques such as speculatively coding and so on to really get the cutting edge performance in the industry. All of that has allowed us to get to $1 per million tokens for Llama 70B, which is one of the cheapest price points in the market. And this continues to go down with the further efficiencies that we keep adding. And of course, we stay on top of the latest models that come out. So Mistral Latex is available. The Mistral Zephyr models are available. Basically, we monitor the demand for models out there, evaluate which ones are the highest quality, and keep adding them to Anyscale endpoints. And that's done within a day of them getting released. Another important design choice that we made was using the OpenAI API. And this allowed people to migrate easily or switch between using closed source models and open source models, and also integrated well with all the existing tooling out there, like LangChain, weights and biases, and so on. And aside from staying at the forefront of models and the performance, we also try to stay at the forefront of features. So Robert touched on function calling, and we launched this 2 days ago. It has gotten surprisingly amazing feedback. And it goes a step further than OpenAI by actually enforcing strict schemas. So this allows you to integrate it into your production applications more easily. We've also seen a lot of people use RAGs, and we recently launched an embedding model to help you with the offline computations. Want to talk a little bit about fine-tuning as well. So we did some internal evaluations, and we wanted to make fine-tuning very accessible and then see if these small models can achieve the same performance on a specific task as larger models, larger closed source models, or larger open source models. And these are some experiments that we ran. So we did functional representation, SQL generation, and a math data set. On SQL, so this dark blue line is kind of the base performance of Llama 7B. And then the light blue is after we fine-tuned the model on some open source data sets. And you can see that for 2 of the 3 tasks over here, we were able to achieve better accuracy than GPT-4. That doesn't mean fine-tuning will work for all use cases. But there are definitely use cases where you can reduce cost and get equal or better performance than closed source models. So I want to walk through the workflow for fine-tuning because it's cool to see how simple this really is, as long as you have a data set. So the documentation is all available on our website. The first step is to create the data files in the OpenAI compatible format. And then all you do is submit a fine-tuning job. You get an email notification 15 minutes later, and then, or however long the fine-tuning job takes, which is typically 15 minutes to an hour. And then you can query the fine-tuned model on Anyscale endpoints. Yes, so here's my notebook. This notebook is also available in our meeting invite. So the first step is preparing the input data. For this task, we took a SQL data set that's available in this Spider website. And then you format it based on the system, user, and assistant prompt format that OpenAI API supports. So let's run this. I created my files on disk, and now I want to upload my training and validation files to Anyscale endpoints. And all of this uses the OpenAI API. And these files are a little large, so it takes about 7 to 10 seconds to run. There we go. So the files are uploaded, and now I can just submit a fine-tuning job on Llama 7B. We also support Llama 13B and Llama 70B fine-tuning right now. And soon we'll be adding support for Mistral. So the fine-tuning will obviously take some time, and we're not going to wait on it. So let's go ahead and query an existing model that I trained earlier this morning. So I took a prompt to query some Singer information. On Llama 7B, if I run this query, let's see what it says. So this is not SQL formatted, although it has partially the right SQL in there. And now when we run it through our model, it gives a nice SQL formatted output that you could plug into your SQL engine. So fine-tuning really works well for these kinds of use cases where it's about correcting the form of the output. It may not necessarily be about like reasoning. And Kurosh, our lead ML engineer, has done a lot of good work and has some blogs out on use cases where fine-tuning works well, um, and how to actually get it to work. And now I'll hand it off to Kiko. Any questions? What's that? The notebook is in the meeting invite, and it's also in the slides that there's a QR code to it. And I think we'll post the slides right after this. You'll need to sign up for Anyscale endpoints. We recently also let you sign up with some free credit, so try it out. Yeah. Yeah.
I can show you.
Yeah. You want to use the clicker or the deck?
I think I'm gonna just go share that way. Let me share my screen. All right. Let me close this. Oops. How do I, give me a second. There we go. Found it. Yeah. All right. Took a minute. All right. Well, hi everyone. My name is Kiko. I work at Arize, and I want to just give you a little demo of how we would troubleshoot a RAG application. It's about what we're going to talk about in this example. A few words first. Arize, our company, work with Jason. Our mission is to help you observe and discover what's wrong and what's good with AI. And in this case, we're going to go through a RAG application. In our company, we have two products. We have an enterprise product and we have an open source product. So today we're going to be demoing the open source product. So if you like it, I'll repeat it later, but if you like it, give us a star. And if there's something you don't like and you would like to see, feel free to contribute. We would love to have you. Okay, so in this case, I went ahead and installed a few. I will share, or I think the slides will be shared at some point. So there's a link to this tutorial. You can go through it yourself. The first few things that I'm going to go through, you simply need to, of course, get your keys and whatnot. I modified the tutorial a little bit so I didn't have to put my keys in the open. And then we use Anyscale to generate embeddings, and we will use those embeddings to basically, once we give in a query from the user, a question, most of the times, then we use the embeddings to access documents in a vector database. And then I'm going to go a little bit quick because what I want to do is get to the demo quickly. So I'm going to go here and just launch the app. And this is what I wanted to see. Let it a moment. This can be run, by the way, locally in your computer, no problem. It takes actually a little bit longer in Colab, for obvious reasons there. All right, now, so far we don't see anything, and I'm gonna just start running queries. Let's see, Let me grab, I'm gonna compute the embeddings. Now, this is a Llama index application, and just for you to get the traces, for you to get this information out of your application, all you need to do is to set up this handler, and it will be automatically be sending information to Phoenix in your local instance. I'm gonna run that. Okay, and I start running queries. And as you see in this cell, we're gonna start running queries. We're gonna start making questions to OpenAI in this case. And we should start seeing, as they complete, we should start seeing them appear in Phoenix. Now, if you want to, I'm gonna now maximize this. Let's say you want to do some introspection here. I would suggest to stop the streaming, otherwise you're going to click and click where you don't want to. So for instance, this is very powerful because you can see in one of, you get all of your spans, and let's click on this one. We know that the user submitted a query that's Arize to for a batch model. The output, yeah, sorry, I have the Zoom thing in front of me, so let me move it. There you go. So the output is the answer that we see. So this is all you would see if you just submitted the query to the system, input, output. There's a lot more going in. We have the retrieval step where the embeddings are computed, they're sent to the vector database, 2 documents are retrieved, and then we synthesize, we pass those 2 documents to the LLM returns a response. So all of this system is available to you to, as they were saying in the far side, see what part of this application is actually falling out of place, or which part is maybe having a huge latency more than they should be, or the process is not good. For instance, we can look at the retrieval process and we can see the documents that are retrieved. I do want to drive your attention a moment here, because there's evaluations, and there's dash, 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 there's nothing there. I will come back to it because we just released something that is very cool that was a big part of the talk with Jason that I really want to show you later at the end. But think of all the information and how easy to access. I'm going to click the stream again, and we're going to see appear the rest of all the queries that we run. So I think that we want to see, let's say the latest, I think it was a query here that's 7 seconds. Let's see this one. It's actually the one that I selected, curiously enough. So we can see that we have for instance, the attributes. We can see the JSON, what was sent to the individual steps of the system. We can see the embedding step. We can see that this embedding was actually an embedding generated by the ADA model, and it has 36 dimensions. Is that the dimensionality you went for? Is that not? You can access all of this information. Of course, the LLM itself, this is what we actually gave the LLM component of the entire pipeline. We gave it a system instruction. In this case, we're an expert Q&A system that is trusted around the world, blah, blah, blah. And moreover, we give it this prompt, which is going to be a huge part of the experimentation, at least what we have seen, where you can say, all right, this is the context that I'm going to provide, and then the context is given in here, in the retrieval steps. This is the documents that it has retrieved. And you can iterate this prompt, you can iterate a bunch of this, and you can actually filter by, so for instance, just say you want to go and only want to inspect the LLM step of all of your pipelines. You're not interested in seeing anything else. You can do a span can, yeah, LLM, screw up the autocomplete. There you go. And there you go. Now you can see all of the spans only on your LLM. If you don't want to see anything else. The difference between traces and span is just the trace is a hierarchical order and grouping of these spans. So this is very useful to trace and see what's going on with your application. But we also offer you, I'm going to close here, come back to the tutorial, the same data. Now imagine that you want to do some exploratory data analysis, some EDA here. You can also do that with Phoenix. You're just going to execute this second part. We get another link, we open. Everything that I'm opening is because I like to be in open, but you can actually see everything I'm seeing within the notebook. You don't need to have your browser open. I like having real estate. Please try this in your local computer. It goes a lot faster too. For instance, now let's see, we pass the system a prompt, we get the system a response. We were able to actually embed this prompt and responses as well. Both, not only we embedded the prompt and the query that we gave the system for, to the access of the documents that were relevant, we also embedded the response. And this has some really good advantages when you want to do exploratory data analysis. For instance, in this picture that you see, on the top, you see the accuracy. So we asked users, was this relevant to you? Was this a good answer to you? And some people said yes, some people said no, some people didn't say anything. And as you see, the performance around July 15th, July 16th wasn't really good. So I'm going to click there, and I'm going to compute. This is if you're familiar with UMAP on dimension reduction techniques, it takes these large embeddings that your data is represented as, and it makes it so we can see it in 3D. So immediately, I see that, well, I'm going to look at the bottom left. You don't see it very well, but let me just tell you, in the bottom left right here is a legend that says the orange points, you can actually resize your points. The orange points are incorrect assumptions. The blue points are correct ones. So if I can actually see immediately, there's here a group of points that everything is incorrect. There's not a single correct answer there. Sometimes, especially when we have more points, these clusters, these maps are not as easy as identifiable, but we help you, giving you automated clustering. So we group the map automatically for you. And look at cluster 0 has accuracy 0, meaning all of the answers are wrong. If I click on it, unsurprisingly, we've selected the one that we saw down there. Now I can go into these answers, and we will see very similar results that we see in tracing. In tracing, you will see, hey, this document you retrieved was irrelevant. And I'll get to that in a moment when we see evaluations. But now you can see a more holistic view of your data, of not only one run, what went wrong on this run with times and the pieces of your application, but you can see now exploring your data. What are people asking? Where are you doing wrong? Where your system is not being trained on, that's a good one. So for instance, in this one, we can see the OpenAI relevance. This is something that we asked whenever we got the answer, we got the documents, we asked the OpenAI model, hey, here's the question, here's the documents. Was the first document relevant to the question? Was the second document relevant to the question? And the model, this is something that I'm prefacing for what we're going to see next, the model told us that both documents were irrelevant. So I'm not surprised that the answer, given that we gave it two irrelevant documents, the answer of the model was actually incorrect, and whoever user actually rated us really poorly. So now we have the tracing for the entire application, a lot very fine-grained, and we have the exploratory data analysis. What I want to do now is kind of give you a first look into how it looks like having the tracing with the evaluations on top, which I'm going to do in a second. So think of, let me just grab this, close it. So think of what we're talking about here. We're saying this data we've generated, but this document has how to generate this data, under following. Just don't want to generate the data while we're speaking. Give me 1 second. Let it run. Okay. This is one of my most favorite releases, Phoenix. By the way, this is how it looks in the notebook. So you know what? I'm going to just demo this part in the notebook. So as you see, we have the same traces as we had before. Now where we had evaluations, before we had dash, 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 dash. It wasn't showing it. Now we have attached to your spans, it comes the evaluation that you asked another language model or another system. You ask, hey, let's say, for instance, we have a evaluation which is a hallucination. We say, hey, given this question, given these documents, does the model make this answer up, or is it factual? Is it rooted on any context that I've given it? And the fact of the matter is that the result of that set evaluation was that it was factual. So the model actually replied correctly. We can actually verify that by looking the following. We can look at the spans the same way as before. And we can see the retriever. The question was, how do I log prediction using Python SDK? Now the retriever says, well, it's giving you a schema. This is part of our documentation, is how you log things in the Python SDK in Arize. You have more details about the schema. So the documents are relevant to the question. You also have these evaluations attached to the individual spans. And moreover, what's even more important than this, given I don't remember who asked for this, but when it comes to explanations, it's not just enough that we have, which is already good. We have not only we have to go one by one, but to have a system that evaluates this for us. It's telling us why. We have these explanations. So if you go to query, sorry, to the retrieval here. Go ahead. On the query too? Query, evaluations. Here you go, my bad. So we have, okay, the evaluation, we wanted to evaluate for a hallucination on this event of the pipeline, on this query. The result was factual. Why was it factual? And now it tells you here. The answer provided is in the line with the information given in the reference text. The reference text, remember, was the two documents where it was pieces of our documentation on how to log things through our Python SDK. Let's try another one. Let's try one that is actually not correct. Let's try this one. The question is, how do I delete a model in Arize? Now, the output, so to delete a model, you need to, whatever, because I already know it's hallucination, so I'm gonna go to evaluations. Let's actually look at, just for argument's sake, to the retrieval. Let's see the documents that says. The document said, navigate to the custom metric editor. I don't think you're gonna delete a model in the custom metric editor, so probably not good. And in fact, the relevance is telling us this document that was retrieved is irrelevant to the question. It's telling us right there. And it's telling you why. The question is asking instructions on how to delete a model. The reference text provides information about navigating to the custom metric editor. So it gives you a full understanding of what's happening, where your model is going wrong, why, and it gives you a lot more tooling to select what the problems are, where they are, and go directly to the issue. What I showed before for the EDA, it lets you group a big chunk of questions that say, hey, all of these questions have problems. And you can export everything I've said in both sides of the UI. You can export all of this back to your notebook, filter and work on it on your data frame as you would to do any data science for your team. You can send it. You can filter, you can slice, say, hey, this is my problem. Here's your data frame. Give it to your data science team. And that will be all. Thank you. Like, if you have any questions? Any questions? Yeah.
How much you guys use to the evaluation?
We've done quite a bit. I don't know the specific example. Do you know?
Yeah, GPT-4 is.
GPT-4?
But like depending on your evals, you can sometimes use smaller models. I highly recommend GPT-4. Many struggle. Many evaluations struggle with smaller models. So this is GPT-4, and no fine tuning was done. It's just GPT-4 with an evaluation task.
Let me just, for argument's sake, let me just, okay, the internet, it's, yeah, go ahead.
Do you have AI agent?
Say that again? I'm not familiar with it.
The question was AI agent functionality.
Oh.
Yeah, from an observability perspective, we support like AutoGen, example of a framework like chain, like long index. All those are kind of supported. We do tracking, so multi-turn, conversational stuff, all available for. In our case, it's observability, so it's typically observability and evaluation of those.
Yeah. Yeah, and
Typically, we're hooking into frameworks that empower you to develop. And some people, a lot of people are just building internal infra themselves.
yeah. So if you want to also learn how to send, how do we like receive this information, you can see like in the step that I had set global Arize, set global callback at Rise Phoenix. That's something we have with Llama Index. I think we also have with LangChain. So you can see how we implemented those callbacks, and if you want to implement your own, this is open source. Yeah, this is actually the GitHub, so I just have it here. Give us a star. Feel free. You're welcome. Go ahead.
Yeah, I'm curious, curious if you all, obviously the explanations, really useful. Human reviewers, have you been, has that been going into automatic based evaluation processes? Better results when you reading, prompted and rating, invocation, look at.
Yeah, I think there's I think we have bigger visions on where this goes. Actual text evaluations are helpful, but together better automation on top of everything. Not, I would say, still in the early days. So we're probably at a stage where we're trying to slots versus.
Awesome. Well, thank you.
Yeah, thanks for joining us. And have a happy holiday season.
There you go.